For example 2, we've got 2x plus 4y plus z equals 1. We've got x minus 2y minus 3z equals 2. And x plus y minus z equals negative 1. That bottom one looks kind of nice and simple. It might come in handy later, so I'm actually going to move it so we don't start canceling some stuff out. So what I'm going to say, let's move and flip-flop rows 1 and 2. So by moving rows 1 and 2, we're going to end up with the new row 1 would be x plus y minus z equals negative 1. We'd have the second row is still x minus 2y minus 3z equals 2. And the last one now is what used to be the first one, 2x plus 4y plus z equals 1. So now taking a look at this, again, we're trying to keep all three variables in the first row. We've got it. They're nice and simple right now. We're going to try to get the second row down to just be a y and z. So what we can do is I'm going to say let's take the opposite of row 1 and add it to row 2. So we're going to take the opposite of everything in row 1. So that's going to give us negative x minus y plus z equals positive 1. And we're going to add that to row 2, which was just x minus 2y minus 3z equals 2. So when we add these, sorry, not subtract, but when we add these together, the x's cancel out, which is nice. We have negative y plus negative 2y gives us negative 3y. And z plus negative 3z is going to give us negative 2z. And then negative 1, that was a negative there, my apologies. Negative 1 plus 2 gives us, oh, no, I'm sorry, I undid that. It's positive still, because we took the opposite of everything from row 1. My apologies. So we got 1 plus 2 gives us 3. Awesome. So now we can replace row 2 with that, so that's only got y and z. So row 1 is still that now new simplified version, x plus y minus z equals negative 1. Row 2 we're going to replace with what we just found. We got negative 3y minus 2z equals 3. And row 3 we've got 2x plus 4y plus z equals 1. Now, again, we're trying to get it so that the first row has all three variables. Got that. Second row has just y and z. Got that. Now we're going to try to pick away and work at the third row and try to get rid of the x and the y so that it only has z. We've got some options. What I'm going to do is I'm going to focus just on the x first. So what I'm going to say, let's take negative 2 times row 1 and add it to row 3. So we're going to take the opposite and multiply everything by negative 2 from row 1. So x times negative 2 gives us negative 2x. Y times negative 2 gives us negative 2y. Negative z times negative 2 gives us positive 2z. And then finally the negative 1 that was in row 1 there is going to be multiplied by negative 2 and giving us positive 2. We're going to add that to row 3. So row 3 was 2x plus 4y plus z equals 1. From here, again, we're going to add these two rows together. So the negative 2x and the positive 2x cancel out. We got negative 2y plus 4y gives us positive 2y. We have 2z plus z, that gives us a grand total of 3z. And then the final one, we've got 1 plus 2, that gives us 3. So now we're going to replace that bottom row with what we just found. So first row hasn't changed since the last step. Second row hasn't changed since the last step. Third row, now we're going to use 2y plus 3z equals 3. Now, again, we're trying to eliminate each variable, so that way the third row only has a z in it. Now, the tricky thing about that one is we got to get rid of the y. But the only thing that has just a nice simple, well, sort of simple y in it is row 2. We're going to have to get a little creative. What I'm going to say, let's take 2 times row 2 and add it to 3 times row, 3 times row 3. So what that's focusing on, we're focusing on just these y's here. The only way we can get a negative 3 and a 2 to become opposites of each other is to multiply the negative 3 by 2 and the 2 by positive 3. So when we do that, negative 3, we're going to take all of row 2, multiply by positive 2. We got negative 6y, and then the negative 2z multiplied by 2 gives us negative 4z. And then the other side, 3 times 2 gives us 6. On the row 3, we're multiplying everything over there by 3, so 2y times 3 is 6y. 3z times 3 is 9z. And last one, 3 times 3 is 9. Let's add these together. So we have 6y plus negative 6, or sorry, negative 6y plus 6y cancels out. Negative 4z plus 9z gives us 5z. And 6 plus 9 gives us a grand total of 15. So we have 5z equals 15. Therefore, simplified, divide both sides by 5, we get z equals 3. So now we have our final equation to put in that final row. So we got x plus y minus z equals negative 1. We have negative 3y minus 2z equals 3. And we have finally just z equals 3. So we're going to take this information and start backtracking. So we already know z equals 3. That's going to be our final coordinate. So in fact, I'm going to start writing my coordinates off to the side here. We're going to have x, comma, y, comma, z. And we already know z is 3. So let's put that there. And we're just going to fill in these other two blanks here. So let's start plugging it in, plugging it into the previous one. So we're going to take the z and plug it in for, well, z equals 3, plug it in for each of the z's we see. So we got 3y minus 2 times our z value of 3 equals 3. And we're going to use this to solve for y. So we got negative 3y. Negative 2 times 3 is negative 6 equals 3. To solve for y, we're going to add 6 to both sides. And we end up with negative 3y equals positive, wait, scratch that, sorry. Negative 3y equals 9. And then to solve for y there, we're going to divide both sides by negative 3. And we end up with y equals negative 3. So that's our second solution, our y value there. Now to find our third one, we're going to plug the y and the z back into that first equation. So we have x, the one we're trying to find still, plus our y value of negative 3, minus our z value, which was 3, equals negative 1. Well, the nice thing about the way this is set up is negative 3, well, actually those kind of work together. So we have negative 3 minus 3, so we have x minus 6, goodness gracious, Mr. Brasser, equals negative 1. To solve for x, we're going to add 5 to both sides. Sorry, thinking ahead to the answer, sorry. Add 6 to both sides, and we end up with x equals 5. So that is our third and final solution for this problem. So we have 5, negative 3, and positive 3.